Good morning everyone, this is Dr. Harshavardhan Hilli, Assistant Professor, Department of Genetics and Plant Breeding, PGCA, RPCA, PUSA. So friends, we are going to discuss about PCR and some of the basic aspects in this lecture. So you can just see here the PCR is nothing but it's a laboratory technique which is used to increase the quantity of the specific DNA. That means for amplification of the DNA, we are going to use this PCR. So what happens here is nothing but the DNA synthesis, where the DNA polymerase enzyme will be there, which will be helping into building the new DNA strand using an existing DNA as a template. Okay, so based on the temperature changes, so we are going to give the different temperature ranges here. Okay, so which will be helping in ultimately the separating the DNA strands, allowing the primers to attach, and then finally synthesizing the new DNA. So these are the components that we need to have in order to go for PCR, that is the template DNA, DNTPs, PCR buffer, forward and reverse primers, stacked DNA polymerase, and then thermal cycler. So what exactly happens inside this thermal cycler is, so there are three steps, that is denaturation, annealing, and extension. In the denaturation, which takes place at 94 to 95 degrees Celsius, where a DNA double stranded will be there, which will be converted to single stranded DNA, and the main purpose is providing the single stranded DNA template. Okay, and then annealing, where takes place at 50 to 65 degrees Celsius. So what happens in this step is that primers that will be annealing to their complementary sequences on the DNA template here. Okay, so the main purpose is ensuring the specificity of the amplification. And then extension, which takes place at the 72 degrees Celsius, where intact DNA polymerase will be there, which will be extending the primers by adding the new nucleotides. Okay, so ultimately what happens, synthesizing the new DNA strands will be seen. Okay, so while going for this PCR, you need to have the annealing temperature. So if you want to calculate the annealing temperature, so we need to know how we need to know how to calculate this annealing temperature as well. So for example, if you want to know the annealing temperature, you need to know the melting temperature of that particular primer also. Okay, so by using this particular formula, that is melting temperature is equals to 4 G plus C plus 2 AT. Okay, if you are going to use the particular formula, then you are going to get the melting temperature. Okay, so once you are getting the melting temperature, then ultimately what happens, 3 to 4 degrees Celsius less than that of melting temperature, that will be considered as an annealing temperature of that primer. For example, this is the forward primer and this is the reverse primer. So you need to count the number of nucleotides, that is how much adenine is there, how much thymine is there, how much G is there, how much C is there. So in this particular forward primer, so you can see here, if you are going to use this formula, that is 4GC plus 280, that means 4, and GC, you can see here G is 4 plus C is 4, 4 plus 4 is 8, 4 into 8 plus 280, the 2, A is 6, T is 4, that is total 10. So once you are going to put in this particular formula and then calculate, then you are going to get a value, that is for example 52 degrees Celsius. Similarly, you are going to calculate for reverse primer also. Okay, so it will be also like around 52 here. Okay, so once you are going to get this temperature, you need to do the average of this forward and reverse primer. Here the average of forward and reverse primer is 52, which is a melting temperature. So in order to calculate the annealing temperature, so what you need to do, you need to consider 4 to 5 degrees Celsius lesser than that of melting temperature. So approximately 48 to 49 degrees Celsius is the annealing temperature of a primer. Okay, so this is how we are going to calculate the annealing temperature of the primer. And then there are certain PCR techniques are there. Okay, so with the having a wide applications, the very first one is the conventional PCR, which will be used mainly for the amplification, that is cloning, gene detection and all. And then we are also having the RT-PCR, which is used for gene expression studies, where the RNA will be first converted to cDNA here, and it is also used for RNA virus detection and all. And real-time PCR, it is used for quantitative gene expression studies, so it will be also helping in quantifying the DNA or the RNA. And the more important thing is here the results will be monitored during the PCR cycle itself. So that's why the name is real-time PCR. Here you are going to get the real results during this PCR cycle itself. And similarly the multiplex PCR, so it will be helping in simultaneously detection of multiple genes and all. So you can go for multiple PCR products here using the multiple primers also. Okay, And then the nested PCR, it will be helping in detecting a very low copy DNA. Even if there is a very low copy of DNA, then you can go for nested PCR, which will be having high specificity also here. So the one more important function of this particular application of this nested PCR is, so two PCR cycles with the two primers can be used here, okay, one after the another. That means once the PCR amplification is done, then whatever the amplified product will be there using the first primer, okay. So what happens here, the second primer can be used, okay, so in which it can amplify within the first PCR product. So this is the specialty of this nested PCR. Similarly, we are having the touchdown PCR, where specific amplification of the template DNA, if you are not going to know if you are not knowing the particular annealing temperature of any like a primer, then what you need to do, you need to go for touchdown PCR, where you can give the command of a different temperature ranges here, so that you will be able to identify the annealing temperature of that particular primer. So this is the one of the advantages of the advantage of the touchdown PCR. Similarly, we are having hot start PCR, where the reduced non-specific amplification will be there, and we are also having the allele specific PCR, where SNP detection and mutation, for that purpose we are going to use. Okay, so these are some of the PCR and different types of the PCR along with the different applications that we are having. So this is what I wanted to discuss in this particular short lecture. So hope everything is clear. If still any doubts are there, then you are free to reach to me. Okay. Thank you.